Imagine standing in a pitch-black cave where you can't see your own hand in front of your face. The darkness is absolute, and your senses strain to pick up any clue about your surroundings. You're desperate to know what surrounds you: walls, obstacles, or perhaps a way out. Every sound, every faint echo, becomes a lifeline. So, you shout into the void, your voice bouncing off unseen surfaces, hoping for a response. The time it takes for the echo to return tells you how far away the wall is. The louder and clearer the echo, the closer and more solid the object. This is the core of radar. Send out a signal, wait for the echo, and map the unseen. It's like echolocation, but on a technological scale. Radar, short for radio detection and ranging, uses radio waves instead of sound, but the principle is identical. It's a way for machines to see in the dark, just as you did in the cave. A radar station blasts powerful pulses of energy into the sky. When these invisible waves hit an object, some of that energy bounces back toward the source. The receiver picks up these faint echoes, and computers instantly calculate not just distance, but also the speed and direction of the object. It's like giving sight to machines, allowing them to track what the eye cannot see. For decades, radar has been the eye in the sky, revealing what's hidden from view, whether it's a plane, a storm, or a ship lost at sea. Conventional aircraft with their smooth, metallic bodies reflect radar waves powerfully, just like a solid wall in that cave reflects your shout. The result? A bright, unmistakable blip on the radar screen, instantly revealing the aircraft's presence and position. But what if instead of reflecting the shout, you could absorb it or deflect it away, leaving no echo behind? What if you could become invisible to radar's probing eyes? Stealth is about breaking the cycle of shout and echo, becoming a whisper, not a wall. It's about making the return signal so faint it's almost impossible to detect. It means reimagining aircraft shape and materials to avoid detection, using angled surfaces, special coatings, and advanced composites to scatter or absorb radar waves. The goal is simple but profound: to slip through a sky filled with probing waves, leaving only silence behind, and passing unnoticed through the world's most sophisticated defenses. This is the science of stealth, a journey into the art of vanishing, where technology and imagination combine to outwit the invisible eyes that watch the skies. The first secret to radar invisibility is shape. The way an aircraft is designed, its very outline, can mean the difference between being seen and vanishing into the sky. Think of angled walls in our cave. Sound bounces away, not back. The same principle applies to radar waves. If you can control the angles, you can control what is reflected. Stealth aircraft are built from flat panels and sharp angles, scattering radar energy in harmless directions. These surfaces act like mirrors, but instead of reflecting light, they redirect radar beams away from their source. The F-117 Nighthawk, the first true stealth jet, looked more like abstract art than a plane, every facet calculated to deflect radar. Its jagged, faceted body was revolutionary, breaking away from traditional aircraft design. Modern jets like the F-22 and B-2 use smooth, continuous curves thanks to advanced computers, to achieve even better stealth and aerodynamics. These flowing shapes blend science and art, making the aircraft both elusive and efficient. Every edge, curve, and surface is aligned to channel radar waves away from enemy receivers. Nothing is left to chance. Even the tiniest misalignment can compromise the aircraft's invisibility. Even tiny details matter. Cockpit canopies are coated to reflect radar, weapons are hidden inside, and landing gear is tucked away to avoid detection, and even screws are aligned to avoid stray reflections. Every fastener is flush, every seam is sealed, all to keep the aircraft's signature as small as possible. The result? A radar signature as small as a bird. To enemy radar, a billion-dollar jet can look like a harmless sparrow. In stealth, a single misplaced panel can mean the difference between invisibility and exposure. Perfection isn't just a goal, it's a necessity. It's a symphony of shapes, all designed for one purpose: silence. Each component must work in harmony, orchestrated to defeat detection. Every line is a calculated deception. The aircraft's form is a puzzle, designed to trick the eye and the radar alike. The art of stealth is geometry in motion. As the jet slices through the air, its shape constantly works to remain unseen. The ultimate goal, to disappear from the radar's gaze, leaving only silence and mystery in its wake. Shape alone isn't enough to make an aircraft truly stealthy. While the unique angular design of stealth jets helps deflect radar waves, it's only part of the equation. To truly disappear from radar, stealth jets must also absorb radar waves, not just bounce them away. Enter radar-absorbent material, or RAM, a high-tech skin that transforms radar energy into harmless heat, making the jet much harder to detect. One of the most famous types is iron ball paint, filled with microscopic iron spheres. When radar waves hit these tiny balls, they vibrate, converting the energy into warmth that simply dissipates. Multiple layers of RAM, each engineered to target different radar frequencies, ensure broad-spectrum protection against a wide range of detection systems. Early RAM coatings were delicate and prone to damage, requiring constant maintenance and careful handling by ground crews. Today, modern versions are much tougher, often built directly into the aircraft's structure, using advanced composite materials for greater durability and longevity. Leading edges, engine inlets, and even internal components are coated or constructed from RAM, preventing radar from bouncing off hidden or hard-to-reach surfaces. The ultimate goal is to eliminate any hard surfaces for radar to find, both inside and out, creating a seamless, elusive profile. Every inch of the jet acts as a shield, soaking up radar energy like a sponge and leaving little for enemy sensors to detect. It's a deep, layered defense. Deflect what you can, absorb the rest, and leave nothing to chance. The result is a soft aircraft, one that's nearly invisible to radar and can slip through enemy defenses undetected. In the end, stealth is as much about what you're made of as how you're shaped, an invisible armor for the skies. Radar isn't the only threat. Infrared sensors hunt for heat. Jet engines burn hot, leaving a glowing trail for heat-seeking missiles. Stealth jets cool their exhaust with wide, flat nozzles, mixing hot gases with cold air to lower their infrared signature. The B-2 hides its engines deep in the wing, venting exhaust over the top to shield it from ground-based sensors. The F-22 and F-35 inject cool air into the exhaust, further masking their heat. Special coatings and internal cooling keep the skin from glowing at high speeds. Every source of heat, from electronics to the pilot, is managed and shielded. The goal, blend into the background heat of the sky, making lock-on nearly impossible. True stealth means taming both radar and heat. The pursuit of invisibility has produced some of the world's most remarkable aircraft. The B-2 Spirit, a flying wing, designed for deep penetration missions, the pinnacle of stealth geometry. The F-22 Raptor, the first operational fifth-generation fighter, combining stealth, agility, and advanced sensors for air dominance. The F-35 Lightning II, a versatile network stealth fighter, acting as a battlefield quarterback for Allied forces. Stealth isn't just about hiding, it's about knowing and sharing information. Russia's Su-57 balances stealth with agility, using S-shaped intakes and internal weapons bays to reduce its radar cross-section. China's J-20 Mighty Dragon, with its canard delta shape and internal weapons, signals China's rapid progress in stealth technology. Each design is a unique answer to the same challenge: how to disappear in plain sight. The race for stealth is global, and the sky is the proving ground. These jets are the masters of the unseen. Stealth is a never-ending race between hiding and seeking. As soon as one side perfects invisibility, the other invents new ways to see. Modern stealth jets are optimized for today's radars, but tomorrow's systems will adapt. Low-frequency radars, with longer wavelengths, can sometimes detect what high-frequency radars miss. The next challenge: broadband stealth, invisible across all radar frequencies. Multi-static radar, using multiple receivers, can catch deflected signals from new angles. Future jets must minimize their signature from every direction. A true 3D challenge. Designers are experimenting with metamaterials and plasma stealth, bending or absorbing radar in new ways. Meanwhile, radar engineers are developing quantum and AI-powered systems to spot even the faintest trace. The contest is endless, a silent war in the invisible spectrum. Stealth is the art of not being seen, a technological magic trick that bends reality. These aircraft embody the idea that the greatest power lies in acting undetected, moving like shadows. Their true value is the uncertainty they create. Is the sky empty, or filled with invisible threats waiting above? This doubt can paralyze adversaries and shift the balance of power dramatically. Stealth is both a physical and psychological weapon, shaping the battlefield. As technology advances, the battle between detection and evasion will only intensify further. The future of air power will be defined by this invisible, ongoing struggle. Our perception is limited. The sky may not be as empty as it seems to us. The most dangerous aircraft are the ones you never see coming at all. They are the silent phantoms, commanding the unseen sky above us.